Hey, Vsauce, Michael here, and bananas are fantastic. They're actually one of the most radioactive foods we regularly eat. Sometimes they're difficult to peel from the top. One of my favorite ways to avoid that is to simply hold the banana and snap it in half. Boom. Now it peels itself. It's a wonderful little trick, except when you drop it on the ground. This is unfortunate, but if I picked it up quickly, would it be safe enough to eat? I mean, how quickly do the bacteria on the floor move onto the food? Some people call it the 5-second rule, others the 10-second rule, and still others the 2-second rule. But is there any truth to it? Or is it just something that we say to allow us to eat food off the floor? In 2003, Gillian Clark famously investigated this question. She found that 50% of men use the 5-second rule to eat food off the ground, but 70% of women do. More importantly, she found that even brief contact with a contaminated floor will contaminate food, wet or dry. The Mythbusters found similar results, and a paper published in the Journal of Applied Microbiology got even more technical. The researchers contaminated various floor surfaces with salmonella, and they found that 5 seconds is way too long to wait. Bacteria adhere to dropped food almost immediately, but time does matter. After 5 seconds, they found that the food had acquired anywhere from 150 to 8,000 bacteria. But if left for a full minute, the number they found was 10 times greater. Now, considering it only takes about 10 bacteria of certain strains of salmonella to infect you, you should probably think twice before eating off the ground. Oh, and don't complacently think that you're safe because the floor looks clean or the food that fell on it does. Floors make great homes for bacteria. Also, floors come in contact with the bottoms of our shoes, and the University of Arizona has found that 93% of our shoes are contaminated with fecal bacteria. I've linked all of these studies down in the description. They're great reads, very thorough. But is it true that food dropped on a dirty floor becomes contaminated immediately? I mean, sure, practically speaking, that makes a lot of sense, but instantly? Is there a limit to how quickly bacteria can move from one object to another? Is there an amount of time short enough that were I to pick the food up within it, there would be no way for what it touched to contaminate it? Well, we're going to need to define touch. I've talked about this before on Vsauce and on Thinker, and Minute Physics has a great quantum perspective. But when we say touch, we tend to think of two objects contacting each other with no space in between. Unfortunately, that's not really what happens. At a subatomic level, atoms resist smashing together because their electrons repel. Electrons can be modeled as waves that overlap and interact, but they never touch. There's always space between them. When I touch something or someone, I'm really just feeling their electrons react to mine at a distance. A subatomically small one, but a real one. So if that's the case, how come glue can stick things together? How come lipstick sticks to lips? And how can bacteria on a dirty floor stick to food that's been dropped on it? The positive charge from the protons in an atom or molecule isn't always balanced perfectly in space by the negative charge from electrons. Sometimes a molecule is asymmetrical and this imbalance is permanent, which gives the molecule a constant dipole, so it's like a tiny little magnet. But even in symmetrical molecules, electrons are mobile. At any one point in time, they might happen to find themselves more towards one end of a molecule than the other, creating rapidly fluctuating dipoles, causing the molecule to act like a magnet. If molecules have a lot of energy, they will simply whiz by one another, and their dipoles and those of their neighbors won't matter much. But if you cool them down, slow them down, the dipoles will have more of an effect, which is why molecules tend to stick together as they cool, going from a gas to a liquid to a solid. That's a lot of information about molecules, but it's incredibly important. It's the reason things can get wet. In fact, when you get out of the shower, you on average weigh about 1 pound more than you did before you got wet. It's also the reason capillary action happens. If you dip a napkin in a glass of water, you can watch the water climb up the napkin against gravity. That's because the molecules of water have very strong dipoles, and they're attracted to each other, cohesion, and they're attracted to the molecules of the paper, adhesion, more strongly than gravity pulls them down. If you want to learn more about intermolecular forces, I've put a bunch of links down in the description. But here's my question: how quickly do those forces act? Can two surfaces come into contact briefly enough that their molecules don't have time to be influenced by intermolecular forces? Well, for this, we're going to need molecular dynamics. Molecular dynamics is the computer simulation of the physical movements of atoms or molecules. For instance, this is a simulation of a single copper atom depositing on a copper surface. Notice that the timer up there is counting off hundredths of a picosecond. These simulations need to have a narrow enough time step to account for the fastest molecular vibrations of the material, including everything from wagging to scissoring. Typically, time as brief as a quadrillionth of a second is taken into account. So the 5-second rule may be true if we rename it the 1 femtosecond rule. Spend less time on the floor than that, and it's unlikely that room temperature molecules would have time to be influenced by intermolecular forces. Except, oops, I think we've been thinking too small. Intermolecular forces are fun, but objects can become entangled with each other on a macroscopic level. Glue and makeup and other sticky stuff often take advantage of the tiny imperfections, ridges, and nooks and crannies on an object's surface. Sticky things can seep inside and hold on. Even surfaces that seem smooth to us, when you really get down to it, aren't smooth at all. 2 sheets of paper from a phone book may slide across each other quite easily, but multiply that friction by the number of pages in 2 phone books by interleaving the pages, and you've got yourself a monster capable of lifting an entire car. I was recently lucky enough to see this happen in real life. You can check out my adventure over on Fast, Furious, and Funny. It's a new channel. Stay tuned, because we lifted cars with more than just phone books. The adhesion between 2 objects caused by the shapes of their surfaces contributes to friction and is known as mechanical adhesion. It plays a pretty big role in getting floor germs to stick to dropped food. In fact, if 2 surfaces can mechanically adhere but aren't close enough to do so, we wouldn't say they were touching. And so if by definition touching means that you can mechanically adhere to the other object's surface, well, then maybe the 5-second rule shouldn't be known as the 1 femtosecond rule, because if they're touching, it's already too late, and instead the rule should be known as the don't touch food that's fallen on the floor rule. But come to think of it, maybe we shouldn't be eating food that's touched anything, because bacteria are everywhere, including on you right now. There are more bacteria on your body right now than there are people living in America. There are 40 million bacteria in 1 gram of soil and 5 nonillion bacteria on Earth. It's been found that 1 out of every 10 bank cards and 1 out of every 7 bills has fecal bacteria on it. Here's something fun. Go down to the comments section and type the letter V. If you used a mobile phone to do that, congratulations, you just touched 6,281 bacteria. If you're using a desktop keyboard, you're a little safer. You probably only touched about 180. Cell phones are actually one of the most bacteria-ridden things we frequently encounter. If you want to estimate about how many bacteria are specifically on your phone based on how clean you are, the Oatmeal has a really great quiz. You can find that in the description. But honestly, what amazes me the most isn't how dirty our world is or how much bacteria there is. Instead, it's the fact that despite those numbers, we don't get sick more often. Our immune system is amazing, but it relies on the same principles of adhesion that bacteria do. The forces that cause food dropped on the floor to pick up germs are the same forces that we need to fight them. They're the same forces that bring us closer together, whether we like it or not. So keep adhering, and as always, thanks for watching.